Hello, my test tubes. Today I'm going to be making a rather miscellaneous video about how to draw cross sections of cuboids, and later on, hopefully, I'll be able to make one about intersections of parallelepipeds, prisms, and possibly other stuff. I think drawing cross sections of basically anything is very relaxing. You can do it before exams to calm down. Or also, you could just casually start explaining something and then just draw a cross section. And just casually drawing a really good cross section can be very impressive if the person doesn't know the algorithm, because the algorithm is pretty easy. So yeah, that's basically free show-off points for you. Yeah. So starting off, before I begin, I'm going to present this pseudo bad algorithm to find cross sections. So, well, it's not an algorithm; it's some ground rules. Rule number one: a third plane intersects two parallel planes to form two parallel lines. So, if there was a third plane intersecting the front plane here and the back plane here, then it would intersect both of them in two lines, and those two lines are going to be parallel. And then rule number two: if two points in the same plane belong to a second plane as well, so does the line connecting them. So if this point and this point, they lie on the same plane, if they also belong to a plane that's cutting this plane at a certain angle, then so does the line connecting them. And then third point is look for the tetrahedron, and I'm going to explain what look for the tetrahedron is all about, and that's basically the thing that will help you draw any cross section that you like. So, starting off, we know that planes are defined by 3 points, so you don't want to draw just any cross section. You want to give yourself 3 points that your cross section has to go through, and then go from there. Here I've drawn 3 points for these two cases. The points lie on the edges, and here they don't. They just lie anywhere. So, starting with this one, I know that these 2 points are going to lie on the same plane, also lie on the plane cutting them. So this line is going to belong to the cross section, and the parallel line on the back side will also belong to the cross section. Then, extending this line to the intersection of these two planes, so the front plane and the side plane, will give me the point of intersection between this plane that's cutting the cuboid, the front plane, and the side plane. And so because it's the intersection of the side plane and the plane cutting everything, and this point also lies both on the side plane and on the plane cutting the cuboid, then this line is going to belong to the intersection of the two planes. And so this line over here is going to be part of the cross section. And here is where I explain what I meant by the tetrahedron. It's that if you look carefully, this is basically the tetrahedron I was talking about. This over here. So this is the base in between these, and then the sides of the tetrahedron, and then it has a triangle over there. So you're looking for a tetrahedron formed by two sides of the cuboid, or just two sides in general, and the plane lies within this tetrahedron. You can see the plane sort of going out of the paper slightly. It's like this whole thing over here, and you want to find a sort of tetrahedron thing that will show you how the plane lies. So, connecting these 2 points as well, drawing a parallel line on the bottom side, parallel to this side, and a line connecting these two, which also happens to be parallel to the other side, which is good because that means that our whole thing is working. We have drawn a cross section. Great. You can also colour it in, but I don't know how to do that well, or quickly rather. So no colouring in the video. Now, continuing on here, The problem with this arrangement of points is that none of them lie on the same plane, so you're going to find it difficult, just like that, finding a tetrahedron that belongs to that has two of the sides of the cuboid as two of its sides. So, what I suggest you do is draw a projection of each of the points onto the bottom face. So here we have, this is the projection, this is the projection, this one doesn't have a projection because it already is on the bottom plane, and then draw a line connecting the top points. So draw a line connecting the non-projection points, and then draw lines connecting the points of projection with the other points of projection. Yeah? And here you get a sort of angle thing. Yeah, this is the angle. And this is the tetrahedron. So you can see that the plane is going to pass through these 3 points, so the plane is going to be this tetrahedron. And you can see from the drawing that the plane crosses the bottom face in this line over here. So I add this little line in because it belongs to the cuboid, and then the rest of the line doesn't. And I can draw a parallel line over here. And once I've drawn the 2 parallel lines, then for this one I just have to connect these 2 together, connect more lines together. So I know that the side, the right hand side has a cross section that looks like this. So the left hand side is going to have a parallel cross section that's very steep, and then the 2 top and bottom faces. Oh, sorry, not the 2 top and bottom faces. The front side and back side faces are also going to have 2 parallel lines connecting these 2 points that lie on the same face. So they're going to stay connected, and these 2 points that lie on the same face are going to stay connected, and it's good that they look pretty much parallel as well. So got this. And then we're going to do exactly the same thing here, so it doesn't become more difficult if they're not lying on an edge, because we have learnt to do the tetrahedron thing without having to need the tetrahedron to lie within the said boundaries. Also, just to be clear here, because I know the points don't lie on any edges, so they could technically be anywhere. This point lies on the top, this point lies on the side, and this point also lies on the side. Okie dokie. Doing the projection thing again. This projects downwards onto this point, this projects downwards onto this point, this point projects downwards to somewhere like here. Connect the projections just like so. Oh no, this is a bad. And then connect non-projections to make your little tetrahedron thing. Ooh, I really wish I had a ruler, but it's okay. Tetrahedron. Okay, so we have our weird tetrahedron thing, and once again, the plane of it intersects the bottom plane roughly here, I'd say. It's a really uncomfortable angle, giving me something like this, basically. I think, in fact, it's going to be something like this. Yeah, the algorithm is, sorry, yeah, this looks bad, but basically it's like a tilted sort of square, I think. Basically, algorithm is, that shook the whole thing, sorry. is find a tetrahedron and connect the look at how the tetrahedron cuts one of the planes that's part of your cuboid, and then draw parallel lines to those. Like, even if this line fell entirely outside of the cuboid, that would just mean that on the bottom face it probably wouldn't intersect with the cuboid because it lies entirely outside. So you'd have something like some cuts over here instead. But it might intersect with the top plane, and it would be parallel to the plane of the line of intersection with the bottom plane. In any case, so find a line of intersection with one of the planes by using a tetrahedron thing. Then draw as many of those parallel lines as you can. Connect those parallel lines to the points that you've already chosen. So if like I had this parallel, this line and a point here already, then I'd know that these 2 points can be connected, and then I can draw another parallel line here. So what you do is draw a tetrahedron, find one line, good, you found one line, then draw as many connective lines as you can. After you've drawn the connective lines, draw as many lines parallel to those connective lines as you can. Then once again, find connective lines, then draw lines parallel to those connective lines, find connective lines, etc., etc., etc. And that's how you deal with it. You can also have points outside of the tetrahedron, of the cuboid somewhere here, and it wouldn't really change. I can give more examples in a future video. Yeah, have fun, and do tell me if I explained this well, because I don't think I did, and I might do another video where I do it better. Yeah, thanks for watching, and I hope that your exams and showing off in front of your friends goes perfectly well.